Okay, in this video we're going to do an example of the fundamental theorem of calculus. Specifically, we're going to do the integral from radical 3 over 6 to 1/2 of the quantity 1 over 1 plus 4x squared dx. So let's get started. So to do this, we need to remember the fundamental theorem. And the fundamental theorem just says that the integral from a to b of f prime of x dx is equal to f of b minus f of a. But to be able to use it, we need to find f of x. And in this particular problem, I would say that finding f of x is going to be the biggest challenge. So let's see. When I look at this problem, I initially always think these types of integrals, I should probably let u equal the denominator of this thing. So if I let u equal the denominator, then I need to figure out what du is and see if it works out. So du is going to be 8x dx. The problem is if you look at the original problem, there's no x in the numerator, and we can't really fix that. There's no way to like multiply in an x or anything like that. So this is not the right approach. So if that had been the right approach, I would have been thinking that either I wanted to reverse the power rule, or if that didn't work, I might be thinking natural logs were involved. But since it's not the case, I start thinking inverse trig functions. That's kind of the hierarchy or the order in which I go. So I tried to do u substitution. If it works, I think it's probably going to be reversing the power rule. If that doesn't work, I think it's probably a natural log. If neither of those work, I start thinking of the inverse trig functions that I know. And in this case, if I rearrange this a little bit, or just kind of rewrite it a little bit, it actually does look like one of the inverse trig functions, or the derivative of it. It looks a little like arctan to me. So what I'm going to do is I'm just going to let u equal 2x. And if u equals 2x, then du is 2 dx. Or what I really want, 1/2 du is equal to dx. Okay, so those are all the things that I'm going to deal with. And I'm going to make my substitutions now and change the integral. So dx is 1/2 du, but I'm going to take out the 1/2. So 1/2 du, and then 2x was u. So I get 1/2 the integral of du over 1 plus u squared. That's perfect because that's exactly the derivative of arctan. So I get arctan of u and then plus c. Then u is equal to 2x. So it's 1/2 tan inverse of 2x, and then plus c. Since we're doing a definite integral, we don't actually need plus c in this case because f of b will have a plus c at the end. F of a will have a plus c at the end. So when we subtract them, the c's just cancel out. So we don't really need it for these purposes, but you always want to write it when you find an antiderivative. So what we can do is we can just take our definite integral here and rewrite it as 1/2 arctan of 2x, and then it's going to be such that, or evaluated from, the bottom is radical 3 over 6 and the top is 1/2. So that's the proper notation that you're going to use. And now what we need to do is find f of b and f of a and subtract them. So it's going to be 1/2 the arctan of, I'm plugging in 1/2 first, so 2 times 1/2 is just 1. I'll write that, minus 1/2 arctan of, I'm going to plug in radical 3 over 6. So 2 times radical 3 over 6 is radical 3 over 3. So we get this. Now we have to think about arctan, right? So I know that the arctan of 1 is pi over 4, and then minus 1/2. The arctan of radical 3 over 3, I remember it as being the ugly one, and I think that pi over 6 has a nice sine value and an ugly tangent value. It's a weird way of remembering it, but it's how I do it. So this is going to be pi over 6. And now I need to simplify this. I'm going to actually take out the 1/2 and then just subtract pi over 6 from pi over 4 and get pi over 12. So overall I'm getting pi over 24. So it turns out that our definite integral here from root 3 over 6 to 1/2 of 1 over 1 plus 4x squared is pi over 24. All right, so that's another example that you can look at of using the fundamental theorem. It involved doing kind of a separate just antiderivative, right? So do an indefinite integral. Figure that out and then go back and use the fundamental theorem. I hope you found this helpful, and good luck.